Hello, so in this video, I thought that we could just do a quick little warm-up using radians. So let's say we have a circle here, and we make a angle in it of, start off easy, 1 radian. We can just label this 1 now that we're familiar with radians. So what is this length here? All across here. What's that? X. Well, as we learned, that arc length will be, that x will be equal to the number of radians, 1, times the radius. And now we can just have the fun of choosing a radius. Let's call this radius 2. It's equal to 1 times 2. So x is equal to 2, right? Alright, let's try a different one. Alright, so let's say we have a new angle this time. This angle is going to be, let's make it something harder. Let's say this is, what would be a good one? How about 3/4? That's hard to read. Let's say 3/4 pi radians. We're gonna practice not using rad because it's not actually written when you're doing them in problems, so we're going to get used to that. And our r is equal to 6. Alright, so what is this arc length here? Let's give it 2 lines to show it's different from the r. So as we learned, this x, we can call it, will be equal to the number of radians we have times the length of the radius, right? Because this is just expresses how many radiuses make up the arc length that it forms. So we can just multiply them. This is how many radiuses there are. Let's see what the length of that is by multiplying by the length of each radius that's in here. So is equal to 3 pi over 4 times 6. And that is obviously equal to, let's see, 3/4 times 6, 18 over 4 pi. And that is equal to 9/2 pi, or you could just write 4.5 pi if you prefer that. Alright, great. Let's do one more example. Alright, so this time let's have one that goes a bit further around. Let's have a really obtuse angle. And let's say this is, what does that look like? I'm going to say that that looks like, what would be a good one? I'm trying to think now. 5/3 pi. That seems good, right? And you can do it, and that turns up being 180 and then another 2/3. So what is this arc length if our radius is 71? There's a fun number. Well, this x, we could call it x, we don't have to call it x, will be equal to our radius, or let's do our number of radians first, just to keep things consistent, times our radius. Alright, and that is equal to, let's see, 355, right, yeah, over 3 pi times whatever unit you're measuring in. I'm not going to simplify further, unless you want the calculator approximation, which I will tell you now. That is 355 over 3 times It's approximately equal to, even with the times pi, 372. Which is interesting, right? So, this was a very short video, but I hope that it helped understand what radians can be used for. Thanks for watching.